Welcome fellow learners. In this video, we will explore how to utilize a multimodal LLM for signature matching. Specifically, we will be working with MiniCPM-V 2.6, a newly released open source multimodal LLM. This model is built on SigLip-400 million and Qwen2-7B, boasting a total of 8 billion parameters. It's designed for various tasks including image and video understanding, in-context learning, OCR, and multi-image analysis. In this tutorial, we will focus on the model's multi-image understanding capabilities for signature verification. Let's dive in and jump into the implementation part. For the implementation part, we are going to utilize Google Colab Workspace. So we first need to connect to a GPU. So you can click on this runtime, then click on this change runtime type and then select this T4 GPU and click on this save button. And then you can connect to T4 GPU with this button. Now, once you are connected to that T4 GPU in this Google Colab Workspace, we first need to install few required libraries. We need to install flash attention, bits and bytes, and accelerate libraries. So let's run this cell. This flash attention library will be required to basically boost the inference part, basically enhance the inference part. Then this bits and bytes library will be required to quantize this model, and this accelerate library will be required to facilitate our inference. So let's wait for a while until these libraries are being installed. Now all the required libraries are being installed. So in the next step, we are going to utilize this bits and bytes config module from transformer to basically quantize this MiniCPM-V 2.6 model. So let's run this cell. Over here you can see that I pass this parameter load in 8-bit equals to true, which will make sure that this MiniCPM-V 2.6 model will get quantized to 8-bit. So after that, we can utilize this auto model module from this transformer to basically download this MiniCPM-V 2.6 model and then import it in this particular notebook. So let's run this cell. In this particular auto model module, I have utilized this from pretrained function where I have passed these parameters. So this last parameter you can see, I have passed this bits and byte config over here, which will make sure that it gets quantized to 8-bit. And then here I have passed this device map equals to CUDA, which will also make sure that the model will be loaded in GPU only. So after that, I have used this model.eval function to basically make sure that model runs for the evaluation part. And then after that, I have utilized this tokenizer to load the tokenizer for this particular MiniCPM V 2.6 model. And here I have passed this particular path, which I have copied from this open BMB MiniCPM V 2.6 path, so that this only loads tokenizer for this MiniCPM V 2.6 model. So over here you can see that it is already downloading this model, and if you go through this files tab of this Hugging Face page of this MiniCPM V 2.6 model, you can see the size of this model. All these saved tensor files are related to model, and you can see it is of around 14-15 GB of size. So that's why we need to quantize this model. Otherwise, with only having 15 GB of GPU, if you see the resources, we are only having 15 GB of GPU, and if we do not quantize and load it in either half precision like 16-bit or full precision like 32-bit, we won't be able to do inference in this free version of this Google Colab. So that's why we have quantized this model to 8-bit. So let's wait until this model gets downloaded and loaded in this particular notebook. Now the downloading has been completed, and if we see the resources and let's see how much GPU it is currently using. Now you can see it has loaded this model, this MiniCPM-V 2.6 model, all the 4 saved tensors files, and it is currently utilizing 9.5 GB of GPU. So that's great. By quantizing this model, we are able to load this model. Now in the next step, we are directly going to utilize its multi-image understanding functionality of this particular MiniCPM-V 2.6 model, and we will see if we can do signature verification or signature matching with this MiniCPM-V 2.6 model or not. So for that part, let's first upload few signatures, like some matching signatures, some not matching signatures. We can get the data, this signature data from Kaggle. Let me show you the link from where you can download this signature data. So from this particular workspace of this Kaggle, this signature verification dataset, from here you can download all the signature data whichever you require. So like here are 2 folders, test and train both. So you can see the signature files over here. We can also visualize what kind of signature files are here, like these signatures. You can see matching signatures over here in the same folder. There will be matching signature, and if you go to this different folder, there will be not matching signatures with the previous one. So you can download these signatures and then you can upload it in your Google Colab. So let me upload in this particular Google Colab. So you can see I have uploaded these signatures. So let's visualize few of them. On the right side you can see these signatures. So this is signature A, and let me visualize another signature. So this is signature B. So we can clearly see that these two are different signatures. So let's run this particular MiniCPM-V 2.6 model and let's see how does this respond. So like I have passed this prompt to it as it is multimodal LLM. So along with these two images, these two multiple images, I can pass a prompt to it also. So like I have given provided two signatures, find out if they are of the same person or not. Just answer with match or no match, nothing else. So let's run this cell and let's see how does this respond. Okay, so it is saying there is no file or directory a.png. So let me see that. Okay, so the file name is sign A and sign B. So let me correct that. Okay, now let's see what is the response that we get from this mini CPM-V 2.6 model. So here you can see we have got the response like no match. Now we can see that it's working right. Let me run for all the images such that we can see if it is working for both matching and non-matching signatures or not. So let's run a loop. So let's first get all the files. So we can do os.listdir and then we can pass the path. As we are already in current directory, it will gives us all the files name, and let me name it as files. Now let's create a list where we will be saving all the file names. So like for file in files, so if it is an image, as we can see all these images are of png type. So if f dot ends with png, so then we can say that it is image. So then we can append it to our that list. And not only, okay, so it will work as we are in the current directory only, so we can directly add that file to that particular list, and then let's print that list. Now we have this all these images in this particular list. So let's copy this code and run it in a loop such that we can see if it is working for all the images or not. We can remove these as these are not required, and then run a loop for each of these images in this particular list. We can do another loop such that we can combine each one of them with another image in the list. So we will do that, and then we will pass it in this particular message list, and then this message list will be passed to our model. So instead of this image 1 and image 2, I will be passing this image and image 2, and then we need to basically indentate it. And along with this answer, I will be also passing name of these images. So like image and image 2. One more thing is like image 2. Okay, so one thing is like we also need to read that. So for that part, we will be copying these two. Okay, so we can do over here like image 1 and image 2. So we will be just passing that image and then image 2, and then we can directly pass these two, image 1 and image 2, over here. That will solve this problem. Now we can run this particular cell and let's see does this work with all the images or not. Okay, now we can see sign C1 and sign C1 match, so it is matched with the same image. C1 C3 also match, C1A doesn't match, it should not match because A image is different, B image is different, and C image is different. So all the variant of C image, I have categorized them as underscore 1, 2, 3. So you can see all the C with C should match. All the C with other B and A should not match. So like you can see C with B is not matching. C with C is matching. C with A is no match. C with B is no match. So we can clearly see that it's mostly working. Like it's like sign A and sign B are not matching. Sign A and B1 are not matching. Let me show you all these ABC over here such that you can see the differences between each of these images. So this is sign C, this is sign B, and this is sign A. And when we click on any of other those sign C images, so this is sign C3 and this is sign C. So these two images should match because these are for the same person. So like sign C, sign C1 over here you can see. That's why C sign should match. Other B with B also should match. So like we can see it is mostly working. Like if we see some of them like sign A with sign A matching, sign A with B should not match, and then sign B with A should not also match. So great. You can see this way you can implement this signature verification or signature matching with this MiniCPM-V 2.6 model. This model has lot of capabilities, like you can do image understanding, video understanding, you can do in context learning. So it has lot of application that you can utilize it for. So use it with your own applications and try it out, and ping me in the comment and let me know how does this work with your particular use case. So great. Thanks for making till the end of this video. Goodbye until the next time.